Hello students, how are you? I hope all of you fine now. Today we will discuss the topic Taylor series complex integration chapters. Your subject code, all of you know that PSM 202 for first year engineering students, second semester, civil, mechanical, EC and electrical also. So what is the Taylor series theorem? Let a function fz is analytic within a circle C with center at alpha, then at each point Z inside C. So first one, here what is the meaning of analytic function? Analytic function means at first function will be differentiable. It's differentiable. That means suppose f dash x exists. So now what is the formula? F dash x, f dash z equals to limit. Suppose now we consider the arbitrary point is z0 point. This is the complex analysis. So this, now we take the complex point. This is f dash z0 equals to limit z tends to z0 fz minus f of z0 divided by z minus z0. This is exist and unique, then the function is differentiable, then fz is differentiable at z equals to z0. Then function fz is called the analytic function. Or Cauchy-Riemann equation also satisfied. Cauchy-Riemann equation what? Suppose fz equals to u plus iv. This is our complex function where u and v are function of x and y or constant term and here u equals to real part and v equals to imaginary part. So what is the formula of Cauchy-Riemann equation? CRE equation, short form, Cauchy-Riemann equation is the del u del x equals to del v del y. Del u del y equals to minus del v del x. And obviously del u del x, del u del y, del v del x, del v del y, four partial derivatives will be exist. All are exist. Then function fz is analytic. Next is within a circle C. Within circle is C. This is a suppose closed curve. This is C. It's a circle with center alpha. Suppose this is the alpha. Then at each point Z inside. Z means it's a complex point. All are inside C. That means all points are here interior point. All points are interior point. Inside in C. Okay. So now formula is fz equals to f of alpha plus z minus alpha by 1 factorial f dash alpha z minus alpha square by 2 factorial f double dash alpha z minus alpha cube by 3 factorial f triple dash alpha up to z minus alpha to the power n factorial f of n alpha. This is the formula of Taylor series theorem. Method of f of alpha z minus alpha by 1 factorial f dash alpha. F dash alpha means fz function. This is the fz function differentiable with respect to z at z equals to alpha value. F double dash x is similarly double derivative at z equals to alpha value, and if triple dash is same like third order, and if n is the our n times differentiations. So it can be expressed as summation form z minus alpha to the power n divided by n factorial f of n alpha. Here n equals to 0 to infinity. If n equals to 0, then this form reduced to. Then f of f, then n equals to 1, that form. N equals to 2, next one, third one, and that's now what is the Now we take a problem. Expand fz equals to 1 by 1 plus z in Taylor's series method about origin. This is your question. So first we have to find out some differentiation. Fz equals to 1 by 1 plus z. So at first differentiation, first order, this is f dash z minus 1 by 1 plus z whole square. Next you find out f double dash z, this is the 2 by 1 plus z whole cube. Triple dash z, this is 6 by 1 plus z to the power 4. So this is minus 1. 1 means 1 factorial by 1 plus z whole square, like this one. This is a 2 factorial by 1 plus z whole cube. This is a minus 6, so that is 3 factorial. 3 factorial means 3 into 2, 1 plus z to the power 4. F4, suppose this is the 24 by 1 plus z whole to the power 5. This is 4 factorial by 1 plus z whole to the power 5, and n times, this is nth derivative, and its nth derivative, suppose first time derivative, this is minus 1 factorial by 1 plus z whole square. So obviously this one is minus 1 to the power n, because if n equals to 1, this is minus 1, this is minus, and this is 1 factorial 1 times. So this is n times, this is n factorial by 1 times 1 plus z whole square. So obviously 1 is increased, so this is n plus 1. This is, if n1, minus 1, 1 factorial, 1 plus z, 1 plus 1, 2 whole square, that's 1. If 2, this one, 3, this one, 4 up to this one, similarly. And now, then, I have to find out about origin. So that means our alpha equals to, in that time, is 0. Origin is alpha equals to 0. So first to find out f of 0, f dash 0, f double dash 0, f triple dash 0, f fourth of 0, and f of n 0. So f of 0 means 1 by 1 plus z, this is 1. F dash of 0, this is minus 1 factorial by 1. This is f double dash, this is 2 factorial by same 1. This is minus 3 factorial by 1. This is 4 factorial by 1 up to, and n times is, this is minus 1 to the power n. This is n factorial divided by 1, because 1 to the power n plus 1 is 1. Now using Taylor series formula, a Taylor series formula is fz equals to f of alpha z minus alpha 1 factorial f dash alpha z minus alpha square 2 factorial f double dash alpha z minus alpha cube by 3 factorial f triple dash alpha z minus alpha to the power 4 by 4 factorial f4 of alpha up to z minus alpha to the power n by n factorial f of n alpha, this one. So now f of alpha, or alpha equals to 0, so f of 0, z minus 0, 1 factorial, f dash 0, z minus 0 square by 2 factorial, f double dash 0, z minus 0 cube by 3 factorial, f triple of 0, z minus 0 to the power 4, 4 factorial, f4 of 0, z minus 0 to the power n by n factorial, f of n 0, this one. So now our f of 0 is, already find this one, 1. F dash 0 is minus 1 factorial, plus z square by 2 factorial, f double dash is 2 factorial, this is z cube by 3 factorial into minus 3 factorial, z 4 by 4 factorial into 4 factorial up to, this is z to the power n factorial into, this one is minus 1 to the power n factorial 1. This cancel, 4 factorial, 4 factorial, 3 factorial, 3 factorial, 2 factorial, 2 factorial, 1 factorial, 1 factorial. So now final result is fz equals to, this is 1 minus z plus z square minus z cube plus z4 up to minus 1 to the power n z to the power n. This one. So this is the Taylor series form, and its summation form will be z to the power n minus 1 to the power n equals to 0 to infinity. If n equals to 0, then we get the first term. If n equals to 1, then we get the second term. If n equals to 2, then we get the third term. Okay, so that's why our final result. Okay, I hope all of you understand this, and your task is number 1, expand fz equals to sin z in Taylor series method about pi by 4. Z equals to pi by 4, obviously. Expand fz equals to 1 by z plus 3 z plus 4 in Taylor series method about z equals to 0 or origin, whatever. These two are your tasks. I hope all of you understand this one. Today up to this. Next class. Next day. Okay, bye. Have a nice day.